Question 1. During an internal audit of an organization's ecodesign integration, according to ISO 14006-2020, an auditor is reviewing the environmental performance assessment of a new line of electronic devices. The organization has conducted a life cycle assessment, LCA, for these devices. What critical factors should the auditor prioritize to ensure the validity and comparability of the LCA findings in relation to ecodesign improvements? Option A. Verification that the LCA methodology aligns with established product category rules, PCR, relevant to electronic devices. Option B. Confirmation that the LCA exclusively utilizes primary data collected directly from the manufacturing process. Option C. Examination of the organization's internal documentation regarding the selection of LCA software without reference to external standards. Option D. Assessment of the number of environmental impact categories included in the LCA, prioritizing those with the most significant public perception. The correct answer is A. Verification that the LCA methodology aligns with established product category rules, PCR, relevant to electronic devices. Explanation. The core of this question lies in understanding the relationship between life cycle assessment, LCA, and product category rules, PCR, within the framework of ISO 14006-2020 for ecodesign. An internal auditor assessing the integration of ecodesign principles needs to verify that the LCA methodology employed is robust and appropriate for the product being evaluated. Product category rules, PCR, are essential for ensuring comparability and consistency in LCA studies, particularly when different organizations are assessing similar products. PCRs provide the specific requirements and guidelines for conducting an LCA for a particular product category. They define the system boundaries, functional unit, allocation procedures, impact assessment methods, and data requirements. Without adherence to relevant PCRs, an LCA may lack the necessary rigor and comparability, making it difficult to draw meaningful conclusions or benchmark against industry standards. Therefore, an auditor would look for evidence that the chosen LCA methodology aligns with established PCRs for the product under review. This alignment ensures that the environmental impacts are assessed in a standardized and credible manner, facilitating the identification of ecodesign opportunities and supporting environmental claims. The absence of applicable PCRs necessitates a justification for the chosen methodology, demonstrating its scientific validity and suitability for the product category, but the ideal scenario involves their application. Question 2. During an audit of an organization seeking to enhance its ecodesign integration as per ISO 14006-2020, an internal auditor is reviewing the process for evaluating new bio-based materials for product development. The organization utilizes life cycle assessment, LCA, as a primary tool. What is the most critical aspect the auditor should verify regarding the organization's approach to incorporating biotechnology into its ecodesign framework through LCA? Option A. The detailed documentation of the genetic modification status of all biological organisms used in material production. Option B. The exclusive reliance on third-party certifications for all bio-based materials used in product design. Option C. The comprehensive analysis of all potential end-of-life scenarios for bio-based materials, irrespective of their biodegradability. Option D. The systematic inclusion of specific environmental impact categories relevant to biotechnological processes and bio-based materials within the LCA methodology. The correct answer is D. The systematic inclusion of specific environmental impact categories relevant to biotechnological processes and bio-based materials within the LCA methodology. Explanation. The question probes the auditor's role in verifying the integration of ecodesign principles, specifically concerning life cycle assessment, LCA, and the emerging field of biotechnology within an ISO 14006-2020 framework. ISO 14006-2020 emphasizes incorporating environmental considerations into product development from the initial design stages. Life cycle assessment is a core tool for evaluating environmental impacts across a product's entire life cycle, from raw material extraction to end-of-life disposal. When considering biotechnology, an auditor must assess how potential environmental benefits and risks associated with biologically derived materials or processes are systematically evaluated and managed. This includes verifying that the organization has established procedures to identify and assess the environmental performance of biotechnological inputs or outputs, aligning with the ecodesign requirements. The auditor's focus should be on the systematic integration of these considerations into the design process, ensuring that the organization's environmental management system adequately addresses the unique aspects of biotechnology within its ecodesign strategy, as outlined by ISO 14006-2020 guidelines. This involves checking for the presence of appropriate methodologies for evaluating the environmental performance of biotechnological components, ensuring transparency in reporting, and verifying that these evaluations inform design decisions to minimize environmental burdens throughout the product lifecycle. The auditor's role is to confirm the effectiveness of the organization's processes in this regard, rather than to perform the LCA or the biotechnological assessment itself. Question 3. During an internal audit of a company manufacturing advanced composite bicycle frames, an auditor is assessing the integration of ISO 14006-2020 guidelines. The company has conducted a cradle-to-grave life cycle assessment, LCA, for its primary frame model, identifying significant environmental impacts related to energy consumption during the curing process and the generation of composite scrap during cutting and shaping. The auditor needs to determine the most effective way to verify that the manufacturing process is being managed in alignment with the ecodesign principles outlined in ISO 14006-2020, specifically concerning the LCA findings. Option A. Confirming that the LCA report is readily available and has been formally submitted to the Environmental Department for record keeping. Option B. Evaluating the company's compliance with general waste management regulations and energy efficiency standards unrelated to specific LCA findings. Option C. Reviewing documented evidence of process modifications or investigations into alternative technologies aimed at reducing energy consumption and scrap generation in the curing and cutting stages, directly linked to the LCA's identified environmental hotspots. Option D. Verifying that the company has trained its manufacturing personnel on the basic principles of LCA without assessing the application of LCA results to process improvements. Correct answer is C. Reviewing documented evidence of process modifications or investigations into alternative technologies aimed at reducing energy consumption and scrap generation in the curing and cutting stages, directly linked to the LCA's identified environmental hotspots. Explanation: the core principle of ISO 14006-2020 regarding ecodesign and life cycle assessment, LCA, is to integrate environmental considerations throughout the product development process. When an internal auditor reviews a manufacturing process for compliance with these guidelines, they must assess how LCA data informs design decisions and production improvements. The auditor's focus is on the systematic application of LCA findings to achieve environmental benefits, not just on the existence of LCA data itself. Specifically, the auditor should verify that the manufacturing process has been reviewed and potentially modified based on identified environmental hotspots from the LCA, such as energy consumption during assembly or waste generation from material offcuts. This review should lead to concrete actions aimed at reducing these impacts. For example, if an LCA highlights significant energy use in a particular machining step, the auditor would look for evidence that the company has investigated or implemented more energy-efficient machinery or process optimizations for that step, directly linking the LCA outcome to a tangible improvement in the manufacturing phase. This demonstrates a proactive approach to environmental management as stipulated by the standard. Question 4. During an internal audit of an organization's ecodesign process, guided by ISO 14006-2020, an auditor is reviewing the life cycle assessment, LCA data for a new electronic device. The LCA report highlights significant energy consumption during the manufacturing and end-of-life phases. The company asserts that its manufacturing facility predominantly utilizes renewable energy sources to mitigate these impacts. What is the most critical verification step for the internal auditor to confirm the validity of this assertion and its integration into the ecodesign strategy? Option A. Assessing the overall energy efficiency improvements made to the manufacturing machinery, irrespective of the energy source. Option B. Analyzing the embodied energy of the raw materials used in the electronic device, assuming this is the primary driver of environmental impact. Option C. Examining procurement contracts and energy bills to trace the origin and proportion of renewable energy consumed in the manufacturing facility. Option D. Reviewing the end-of-life recycling plan to ensure it minimizes energy input without verifying the energy source during manufacturing. The correct answer is C. Examining procurement contracts and energy bills to trace the origin and proportion of renewable energy consumed in the manufacturing facility. Explanation. The core of this question lies in understanding how life cycle assessment, LCA data, specifically related to energy sources, informs ecodesign decisions within an ISO 14006 framework. When an internal auditor evaluates a company's integration of ecodesign principles, they must assess whether the environmental impacts considered in the LCA are sufficiently comprehensive and accurately reflect the product's life cycle, particularly concerning energy consumption and sourcing. ISO 14006 emphasizes incorporating environmental considerations into product development from the early stages. A robust LCA for a product heavily reliant on energy would need to scrutinize the energy mix used throughout its life cycle. If a company claims to use renewable energy, the auditor needs to verify this claim through objective evidence. This evidence would typically involve documentation of renewable energy procurement contracts, certificates of origin for renewable energy, or detailed energy consumption data linked to specific renewable sources. Without this verification, the claim is unsubstantiated. The auditor's role is to ensure that the environmental performance improvements claimed are based on reliable data, and that the ecodesign strategy aligns with the organization's environmental policy and objectives. Focusing solely on the operational phase, or on the embodied energy of materials, without considering the source of energy used in manufacturing or during the product's use phase, would be an incomplete assessment. Therefore, verifying the actual source and proportion of renewable energy used across the product's life cycle, as identified through LCA, is paramount for an internal auditor assessing ecodesign integration. Question 5. When auditing an environmental management system that aims to integrate ecodesign principles for service-oriented operations, as per ISO 14006-2020, what is the primary challenge an internal auditor would likely encounter when verifying the application of life cycle thinking to intangible service outputs, particularly concerning the definition of functional units and system boundaries for impact assessment? Option A. Verifying that the organization has implemented specific regulatory compliance checks for each stage of a service's intangible life cycle, akin to product conformity assessments. Option B. Establishing a universally accepted and quantifiable functional unit and clearly defined system boundaries for diverse service offerings that accurately reflect their environmental performance. Option C. Confirming that the organization's ecodesign efforts for services are solely focused on reducing paper consumption and digital data storage, as these are the most visible environmental impacts. Option D. Ensuring the availability of detailed, quantitative life cycle inventory data for all indirect service components, such as the embodied energy in client-provided infrastructure. The correct answer is B. Establishing a universally accepted and quantifiable functional unit and clearly defined system boundaries for diverse service offerings that accurately reflect their environmental performance. Explanation. The core of incorporating ecodesign into a service-based organization, as guided by ISO 14006-2020, involves understanding how to apply life cycle thinking to intangible outputs. Key challenge is defining the system boundaries and functional unit for a service, which differs significantly from a physical product. For instance, a consulting service's environmental impact isn't solely about the paper used in reports, but also includes travel, energy consumption of devices, and the indirect impacts of the advice given. ISO 14006-2020 emphasizes that the ecodesign process should consider the entire life cycle, from service conception and delivery to its use and end of life, even if the end of life refers to the cessation of the service's relevance or impact. An internal auditor assessing an organization's adherence to these guidelines would need to verify that the environmental aspects associated with service provision, including resource consumption, waste generation, and potential pollution during delivery and use, are systematically identified, evaluated, and managed. This involves ensuring that the organization's ecodesign strategy for services actively seeks opportunities for environmental improvement at each stage, aligning with the principles of sustainable development and the overarching environmental management system. The auditor would look for evidence of how the organization translates life cycle assessment, LCA, principles, even if qualitative or simplified for services, into tangible ecodesign actions for its service offerings. Question 6. An internal auditor is reviewing an organization's adherence to ISO 14006, 2020 guidelines for incorporating ecodesign, with a specific focus on how life cycle assessment, LCA data related to noise pollution, has influenced product development. The organization manufactures advanced audio equipment. During the audit, the auditor finds that the LCA conducted for a new headphone model identified significant noise emissions during the product's use phase, impacting user experience and potentially contributing to community noise concerns in dense urban environments. What is the most effective approach for the internal auditor to verify that this LCA finding has been effectively integrated into the ecodesign process for this headphone model? Option A. Assess whether the manufacturing process for the headphones complies with local noise emission regulations. Option B. Examine the LCA report for any mention of noise pollution and cross-reference it with the organization's environmental policy regarding noise control. Option C. Review the product design documentation to identify specific noise reduction features or material choices implemented in the headphone model that are directly linked to the LCA findings. Option D. Recommend that the organization conduct a supplementary LCA focused exclusively on the end-of-life phase of the headphones to identify further noise-related impacts. The correct answer is C. Review the product design documentation to identify specific noise reduction features or material choices implemented in the headphone model that are directly linked to the LCA findings. Explanation. The question probes the auditor's understanding of how life cycle assessment, LCA data, specifically concerning noise pollution, informs ecodesign decisions within an ISO 14006 framework. An internal auditor evaluating an organization's ecodesign process needs to verify that the identified environmental aspects, including noise, are comprehensively addressed throughout the product's life cycle. ISO 14006 emphasizes integrating environmental considerations into product development from the initial concept phase. When assessing noise pollution, an auditor would look for evidence that the LCA, as a tool for understanding environmental impacts, has been used to identify stages where noise is a significant issue. This could involve manufacturing processes, transportation, or product use. The auditor must confirm that the ecodesign strategy then aims to mitigate these identified noise impacts. For instance, if the LCA reveals that the operational phase of a new electronic device generates substantial noise, the ecodesign team should have explored design alternatives that reduce this noise, such as improved casing materials, internal component placement, or fan technology. The auditor's role is to ensure that this connection between LCA findings and design improvements is documented and implemented. Therefore, the most appropriate action for the auditor to verify the integration of LCA findings related to noise pollution into the ecodesign process is to examine the design documentation for evidence of noise reduction strategies implemented based on the LCA results. This demonstrates a direct link between the environmental assessment and the design changes. Other options are less direct or misinterpret the auditor's role. Focusing solely on the manufacturing stage ignores other life cycle phases. Recommending further LCA studies without checking existing documentation is premature, and verifying compliance with general noise regulations, while important, does not specifically confirm the integration of LCA findings into ecodesign choices. Question 7. An internal auditor is reviewing the environmental management system of a construction firm that has committed to incorporating ecodesign principles as per ISO 14006-2020. The audit focuses on a recently completed office complex. The firm utilized a life cycle assessment, LCA, to evaluate the environmental performance of various design options and material choices. Which of the following audit findings will most strongly indicate effective integration of LCA into the firm's ecodesign process for this construction project? Option A. Documented evidence showing that the LCA identified high embodied energy in a specific concrete mix, leading to the selection of a lower-impact alternative material for structural elements and a corresponding revision in the project's environmental performance targets. Option B. The LCA identified potential end-of-life recycling challenges for certain facade components, and the project specifications include a note for future reference regarding these materials. Option C. The project team conducted an LCA study at the conclusion of the construction phase to benchmark the building's environmental footprint against industry averages. Option D. The LCA report is stored in the company's central document repository, and project managers have attended a general awareness training session on LCA principles. The correct answer is A. Documented evidence showing that the LCA identified high embodied energy in a specific concrete mix, leading to the selection of a lower-impact alternative material for structural elements and a corresponding revision in the project's environmental performance targets. Explanation. The question pertains to the application of life cycle assessment, LCA, within the context of ecodesign for construction projects, as guided by ISO 14006-2020. An internal auditor for an environmental management system incorporating ecodesign principles needs to verify the integration of LCA findings into the design and material selection process for a new commercial building. ISO 14006 emphasizes a systematic approach to ecodesign, which includes considering environmental aspects throughout the product or service lifecycle. For construction, this translates to evaluating the environmental impacts associated with raw material extraction, manufacturing of building components, transportation, construction activities, building operation, energy and water use, maintenance, and end-of-life scenarios, demolition, disposal, recycling. The auditor's role is to ensure that the LCA results are not merely documented but actively influence decision-making, leading to tangible environmental improvements in the building's design and material specification. This involves checking for evidence of how specific LCA outputs, such as embodied energy of materials, potential for resource depletion, or greenhouse gas emissions during operational phases, have informed choices about alternative materials, construction methods, or building systems. The objective is to confirm that the ecodesign process, informed by LCA, is functional and contributes to the organization's environmental objectives and the overall effectiveness of its environmental management system in the construction sector. This aligns with the ISO 14006 guideline that encourages the integration of ecodesign into business processes, including design and development, to prevent pollution and reduce environmental impacts. Question 8. During an internal audit of a furniture manufacturing company adhering to ISO 14006-2020 guidelines, an auditor is evaluating the integration of ecodesign principles into product development. The company has identified that the primary environmental impacts of its new modular sofa line are associated with material extraction for upholstery fabrics and the energy consumed during the assembly process. Which of the following approaches best demonstrates the application of life cycle thinking in this context, as expected by an ISO 14006-2020 internal auditor? Option A. Focusing solely on reducing post-consumer waste by designing the sofa for easier disassembly and recycling at the end of its useful life. Option B. Prioritizing the use of locally sourced raw materials for all components to minimize transportation-related emissions without a broader life cycle impact analysis. Option C. Implementing a supplier code of conduct that mandates the use of recycled content in all upholstery fabrics, irrespective of their overall life cycle impact. Option D. Conducting a detailed life cycle assessment, LCA, to quantify the environmental burdens of alternative sustainable upholstery materials and optimizing assembly line energy efficiency through process redesign. Correct answer is D. Conducting a detailed life cycle assessment, LCA, to quantify the environmental burdens of alternative sustainable upholstery materials and optimizing assembly line energy efficiency through process redesign. Explanation. The core of ISO 14006-2020 is the integration of environmental considerations into the design and development process. For furniture manufacturers seeking to incorporate ecodesign principles, an internal auditor would assess how effectively life cycle thinking is applied. A life cycle assessment, LCA, provides a comprehensive framework to evaluate the environmental impacts of a product throughout its entire life cycle, from raw material extraction to end-of-life disposal. When auditing a furniture company, the auditor needs to verify that the company's ecodesign process, as guided by ISO 14006, systematically identifies and addresses environmental aspects at each stage. This includes evaluating the impacts of material sourcing, e.g., sustainable forestry for wood, recycled content for metals, manufacturing processes, e.g., energy consumption, waste generation, product use, e.g., durability, repairability, energy efficiency if applicable, and end-of-life management, e.g., recyclability, biodegradability. The auditor would look for evidence that the company uses LCA data or similar life cycle thinking to inform design decisions, such as selecting materials with lower embodied energy, designing for disassembly, or minimizing packaging. The goal is to ensure that environmental improvements are not localized to a single stage, but are optimized across the entire life cycle, aligning with the holistic approach of ecodesign as per the standard. This systematic evaluation ensures that the company's ecodesign efforts are robust and contribute to overall environmental performance improvement, as mandated by the ISO 14001 framework and elaborated by ISO 14006. Question 9. During an internal audit of an organization's environmental management system, an auditor is reviewing the integration of ecodesign principles as outlined in ISO 14006-2020, with a specific focus on their lubricant product line. Considering the guidelines for incorporating ecodesign, what is the primary area of scrutiny for the auditor concerning the environmental performance of these lubricants? Option A. The extent to which environmental considerations, including potential impacts from raw material sourcing to end-of-life management, are systematically integrated into the lubricant product design and development processes. Option B. The precise quantitative reduction in specific chemical pollutants achieved in the latest lubricant formulation compared to a baseline year, as mandated by regional environmental legislation. Option C. The organization's adherence to the voluntary industry standards for biodegradability of lubricants, regardless of their actual life cycle environmental footprint. Option D. The cost-effectiveness of implementing alternative lubricant formulations that may offer marginal environmental benefits but incur higher production costs. Correct answer is A. The extent to which environmental considerations, including potential impacts from raw material sourcing to end-of-life management, are systematically integrated into the lubricant product design and development processes. Explanation. The question asks about the primary focus of an internal auditor when assessing an organization's implementation of ecodesign principles for lubricants, specifically in relation to ISO 14006-2020. ISO 14006-2020 provides guidelines for integrating ecodesign into environmental management systems. When auditing ecodesign, the auditor's role is to verify that the organization's processes and decisions align with the principles of reducing environmental impacts throughout the product lifecycle. For lubricants, this means examining how the organization considers environmental aspects from raw material extraction, manufacturing, use, and end-of-life disposal. The core of ecodesign is about proactively minimizing environmental burdens. Therefore, an auditor would focus on the systematic integration of environmental considerations into the design and development process, ensuring that life cycle thinking is applied to identify and mitigate potential environmental impacts. This includes evaluating the data and methodologies used to assess these impacts, such as through life cycle assessment, LCA, principles, even if a full, formal LCA is not mandated for every single product variation. The auditor would look for evidence that environmental performance is a key criterion in material selection, formulation, packaging, and end-of-life management strategies for lubricants, aligning with the proactive, preventative approach of ecodesign. Question 10. During an internal audit of an agricultural cooperative's environmental management system, which focuses on incorporating ecodesign principles into their crop production, what is the most critical verification point for an auditor to assess regarding the use of life cycle assessment, LCA data? Option A. The cooperative's compliance with national regulations for pesticide application, irrespective of LCA findings. Option B. The extent to which the cooperative has published its LCA results in peer-reviewed agricultural journals. Option C. The LCA methodology's alignment with agricultural-specific environmental indicators and the representativeness of data collected for farming inputs and outputs. Option D. The number of ecodesign workshops conducted for cooperative members on general environmental awareness. Correct answer is C. The LCA methodology's alignment with agricultural-specific environmental indicators and the representativeness of data collected for farming inputs and outputs. Explanation. The question assesses the auditor's understanding of how to verify the integration of ecodesign principles within an agricultural organization's environmental management system, specifically concerning life cycle assessment, LCA, data for crop production. ISO 14006 2020 emphasizes incorporating environmental considerations into product design and development. In an agricultural context, this translates to assessing the environmental impacts of farming practices throughout the product's life cycle, from cultivation to disposal or recycling. An internal auditor's role is to evaluate the effectiveness of the EMS in achieving its environmental objectives and ensuring compliance with relevant guidelines. When auditing an agricultural organization that uses LCA for crop production, the auditor must verify that the LCA methodology used is appropriate for the agricultural sector, and that the data collected and analyzed are representative of the actual farming operations. This includes examining inputs such as fertilizers, pesticides, water, and energy, as well as outputs like crop yield, waste, and emissions. The auditor needs to ensure that the LCA considers significant environmental aspects specific to agriculture, such as soil degradation, water eutrophication, and greenhouse gas emissions from farming machinery and livestock. Furthermore, the auditor must confirm that the LCA findings are used to inform ecodesign decisions, leading to improvements in environmental performance, such as reducing chemical inputs, optimizing water usage, or selecting more sustainable crop varieties. The verification process should focus on the systematic application of LCA principles to identify and address environmental hotspots within the agricultural production chain, aligning with the broader goals of ISO 14006-2020 to prevent pollution and minimize environmental impact. Question 11. During an internal audit of a manufacturing company certified to ISO 14001-2015 and actively implementing ISO 14006-2020 guidelines for ecodesign, an auditor is reviewing the process for developing new plastic components. The company uses life cycle assessment, LCA, to identify environmental improvement opportunities. What specific aspects should the auditor prioritize to ensure the ecodesign process for these plastic components is effectively integrated and aligned with the standards, considering potential environmental impacts like microplastic shedding and end-of-life management challenges? Option A. Confirmation that the company has exclusively sourced virgin, high-grade polymers for all new plastic components to minimize immediate manufacturing waste. Option B. Examination of the production line efficiency metrics to confirm that energy consumption per unit produced has decreased, without direct linkage to LCA-driven design changes. Option C. Assessment of the marketing materials to ensure they accurately reflect the environmental benefits claimed for the new plastic components, regardless of LCA findings. Option D. Verification that the LCA methodology used adequately addresses the full life cycle of plastics, including potential microplastic release during use and comprehensive end-of-life scenarios, and that these findings are demonstrably influencing design choices for environmental improvement. The correct answer is D. Verification that the LCA methodology used adequately addresses the full life cycle of plastics, including potential microplastic release during use and comprehensive end-of-life scenarios, and that these findings are demonstrably influencing design choices for environmental improvement. Explanation. The question explores the internal auditor's role in verifying the integration of ecodesign principles, specifically concerning life cycle assessment, LCA, for plastic products within an ISO 14001-2015 certified organization that is implementing ISO 14006-2020 guidelines. An internal auditor's primary function is to assess conformity and effectiveness. When examining ecodesign, particularly LCA for plastics, the auditor must verify that the organization has established processes to identify and evaluate environmental aspects and impacts throughout the product's life cycle. This includes ensuring that data used for LCA is robust, that the chosen LCA methodology aligns with ISO 14040 and ISO 14044 standards, and that the results are used to inform design decisions aimed at reducing environmental burdens. The auditor would look for evidence of how the organization addresses specific plastic-related environmental issues, such as microplastic generation, end-of-life management, recycling, waste-to-energy, landfill, and the use of recycled content or bio-based alternatives. The effectiveness of the ecodesign process is demonstrated by tangible improvements in environmental performance, which are linked back to the LCA findings. Therefore, the auditor's focus is on the systematic application of LCA to drive these improvements, ensuring that the ecodesign strategy is not merely a declarative statement, but a practically implemented and verifiable system for environmental performance enhancement in product development. The auditor must confirm that the organization has procedures to collect and analyze relevant data for each life cycle stage, from raw material extraction to disposal, and that these analyses are used to set targets and implement actions for pollution prevention and resource efficiency, as mandated by ISO 14001 and guided by ISO 14006. Question 12. During an internal audit of a company manufacturing advanced composite building materials, an auditor is tasked with verifying the effective integration of ecodesign principles, as per ISO 14006-2020, focusing on life cycle assessment, LCA, aspects of land use. The company's product line utilizes sustainably sourced wood fibers and recycled aggregate. What specific audit evidence would most directly demonstrate the organization's commitment to minimizing land-related environmental impacts throughout the product's life cycle, as informed by their LCA process? Option A. Verification of the company's compliance with local zoning regulations for their manufacturing facility and waste storage areas. Option B. Assessment of the energy efficiency improvements made in the manufacturing process, as documented in their annual environmental performance reports. Option C. Examination of the company's marketing materials that highlight the use of eco-friendly materials in their composite products. Option D. Review of documented procedures detailing the organization's efforts to reduce land occupation and land transformation, impacts associated with raw material sourcing and end-of-life disposal, as identified through their LCA studies. The correct answer is D. Review of documented procedures detailing the organization's efforts to reduce land occupation and land transformation, impacts associated with raw material sourcing and end-of-life disposal, as identified through their LCA studies. Explanation. The question probes the auditor's understanding of how to verify the integration of ecodesign principles, specifically life cycle assessment, LCA considerations related to land use within an organization's environmental management system, EMS, as guided by ISO 14006-2020. When auditing an organization that manufactures composite building materials, an internal auditor needs to assess the evidence that the company has considered the environmental impacts associated with land use changes throughout the product's life cycle, from raw material extraction to end of life. ISO 14006-2020 emphasizes integrating environmental considerations into product design and development. Key aspect of ecodesign, particularly concerning land use, involves evaluating the impact of raw material sourcing, e.g., deforestation for wood composites, mining for aggregate components, and the land required for manufacturing facilities and waste disposal. The auditor must look for documented evidence that the organization has performed or considered LCA data that quantifies land occupation and land transformation impacts. This would typically involve reviewing design specifications, material selection criteria, supplier audits, and waste management plans. The most direct evidence of addressing land use impacts in LCA, as relevant to ecodesign, would be documentation showing how the organization has attempted to minimize land degradation or land conversion for its products, aligning with the principles of sustainable resource management and reduced environmental footprint. This directly relates to the organization's commitment to reducing environmental impacts throughout the product lifecycle, a core tenet of ISO 14006. Therefore, reviewing the organization's documented efforts to reduce land occupation and land transformation associated with its composite building materials, as informed by LCA, is the most appropriate audit finding. Question 13. During an internal audit of an organization's ecodesign process, guided by ISO 14006-2020, an auditor is reviewing the life cycle assessment (LCA) methodology applied to a new product incorporating engineered nanomaterials. The auditor identifies that the organization's LCA software and databases primarily utilize characterization factors and impact assessment methods developed for bulk materials. What is the most significant challenge the auditor should flag regarding the validity and comprehensiveness of this LCA for ecodesign purposes? Option A. The lack of readily available, standardized LCA software packages specifically designed for the assessment of nanomaterial-based products. Option B. The potential for underestimation or omission of specific environmental and health impacts arising from the unique properties and behaviors of nanomaterials at various life cycle stages. Option C. The higher cost associated with acquiring specialized laboratory equipment for characterizing nanomaterial dispersion and reactivity during the use phase. Option D. The increased complexity and time required to collect data on the physical and chemical properties of nanomaterials compared to conventional substances. The correct answer is B. The potential for underestimation or omission of specific environmental and health impacts arising from the unique properties and behaviors of nanomaterials at various life cycle stages. Explanation. The core challenge in conducting a life cycle assessment, LCA, for nanomaterials, particularly in the context of ecodesign guidelines like ISO 14006-2020, lies in the unique properties of these materials and the limitations of conventional LCA methodologies. Nanomaterials exhibit novel physical, chemical, and biological characteristics at the nanoscale, which can lead to different environmental and health impacts compared to their bulk counterparts. These impacts may manifest across various life cycle stages, from raw material extraction and manufacturing to use and end of life. A key difficulty is the lack of standardized, widely accepted impact assessment methods and characterization factors, specifically for nanomaterials. For instance, potential ecotoxicity or human health impacts associated with the release of nanoparticles during manufacturing or product use might not be adequately captured by existing LCA models, which are often based on data for bulk materials. Furthermore, the behavior of nanomaterials in the environment, such as their persistence, mobility, and potential for bioaccumulation, can be complex and not fully understood, making it challenging to quantify their environmental burdens accurately. When an internal auditor reviews an organization's ecodesign process incorporating ISO 14006-2020, they must assess how the organization addresses these specific challenges related to nanomaterials. The auditor needs to verify if the organization has adopted or developed approaches that account for the unique properties and potential impacts of nanomaterials throughout their life cycle. This includes evaluating the data sources used, the selection of impact categories, and the robustness of the assessment methodology for these advanced materials. The auditor's focus should be on the organization's ability to identify, assess, and manage the environmental aspects of nanomaterials in their products, ensuring compliance with the spirit and intent of ecodesign principles. The question probes the auditor's understanding of the primary hurdle in applying LCA to nanomaterials within an ecodesign framework. Question 14. During an internal audit of an organization's ecodesign process, which of the following best reflects the auditor's responsibility when assessing the application of streamlined life cycle assessment, LCA techniques, as per ISO 14006-2020 guidelines? Option A. Confirming that the organization has utilized the most comprehensive and data-intensive LCA software available to ensure absolute precision in all environmental impact calculations. Option B. Verifying that the chosen streamlined LCA methodology is appropriate for the product's life cycle stages under review, adequately documented, and its application demonstrably informs ecodesign decisions to achieve environmental objectives. Option C. Ensuring that the organization has exclusively adopted qualitative environmental assessment tools and completely disregarded any quantitative LCA data to simplify the process. Option D. Validating that the organization has independently certified its streamlined LCA practitioners through an external accreditation body, as stipulated by the standard. The correct answer is B. Verifying that the chosen streamlined LCA methodology is appropriate for the product's life cycle stages under review, adequately documented, and its application demonstrably informs ecodesign decisions to achieve environmental objectives. Explanation. The question probes the auditor's role in verifying the application of streamlined life cycle assessment (LCA) techniques within an organization's ecodesign process, as guided by ISO 14006-2020. Streamlined LCA techniques are employed to make LCA more practical and efficient for ecodesign by focusing on key environmental aspects and reducing data collection and analysis efforts. An internal auditor must assess whether these techniques are appropriate for the product or service, adequately documented, and contribute to achieving environmental objectives. The auditor needs to verify that the chosen methodology aligns with the scope and purpose of the ecodesign initiative, ensuring that critical environmental impacts are not overlooked due to oversimplification. This involves checking for clear criteria for selecting the level of detail, the justification for any simplifications made, and the integration of the results into design decisions. For instance, an auditor might review the process for defining system boundaries, selecting relevant impact categories, and choosing appropriate characterization factors, ensuring these choices are documented and defensible. The auditor's focus is on the process of applying these techniques and the evidence that they are effectively informing ecodesign improvements, rather than performing the LCA itself. This includes confirming that the organization has established clear procedures for identifying and using simplified LCA tools or methodologies, such as screening LCA or qualitative assessments, and that these are applied consistently to support ecodesign decisions and contribute to the organization's environmental performance improvements. The auditor verifies that the organization has a systematic approach to selecting and applying these streamlined techniques, ensuring they are fit for purpose and support the overall environmental management system. Question 15. During an audit of an organization's ecodesign implementation for a new line of electronic devices, the internal auditor is reviewing the lifecycle assessment (LCA) data. The LCA has identified significant potential human toxicity impacts associated with the leaching of certain heavy metals from discarded components into local water sources during the end-of-life phase. Which of the following actions by the auditor would best verify the effective integration of this human toxicity concern into the ecodesign process, as guided by ISO 14006-2020? Option A. Verify that the design team has explored and documented alternative materials or component designs that reduce or eliminate the use of these specific heavy metals, or that end-of-life management strategies have been revised to mitigate the leaching risk. Option B. Confirm that the LCA report includes a detailed quantitative risk assessment for all identified toxic substances, referencing specific regulatory exposure limits for every potential release scenario. Option C. Check if the organization has publicly disclosed the identified human toxicity risks to consumers through product labeling and marketing materials, as per general environmental communication best practices. Option D. Examine the organization's waste management records to ensure that all hazardous waste generated during manufacturing, which might contain these metals, is correctly segregated and disposed of according to national hazardous waste regulations. Correct answer is A. Verify that the design team has explored and documented alternative materials or component designs that reduce or eliminate the use of these specific heavy metals, or that end-of-life management strategies have been revised to mitigate the leaching risk. Explanation. The core of this question revolves around the application of life cycle assessment (LCA) principles within the context of ecodesign, specifically concerning human toxicity. ISO 14006-2020 emphasizes integrating environmental considerations into product development. When an internal auditor assesses ecodesign efforts, they need to verify that potential environmental impacts, including human health risks, are systematically evaluated. Human toxicity in LCA quantifies the potential harm to human health caused by the release of toxic substances into the environment during a product's life cycle. This involves identifying relevant toxicological endpoints, e.g., carcinogenicity, mutagenicity, reproductive toxicity, characterizing exposure pathways, e.g., inhalation, ingestion, dermal contact, and relating these to the emissions identified in the inventory analysis. The auditor would look for evidence that the organization has a methodology to assess these risks, even if qualitative, and that this assessment informs design choices. For instance, if a product's manufacturing process involves a chemical known to be a potent carcinogen, and its end-of-life disposal method could lead to its release into groundwater, an LCA would aim to quantify this potential human health risk. The auditor's role is to ensure that such risks are considered and mitigated through ecodesign strategies, such as material substitution, process optimization, or improved end-of-life management, in alignment with the organization's environmental policy and objectives. Question 16. During an internal audit of an organization's ecodesign integration for product packaging, an auditor is reviewing the life cycle assessment, LCA, data used to inform packaging material selection. The organization primarily manufactures and distributes electronic goods. The auditor finds that the LCA report heavily emphasizes the energy consumed during the manufacturing of the packaging materials themselves, but provides minimal data on the environmental impacts associated with the end-of-life management of these materials, particularly concerning the potential for microplastic generation from certain composite packaging components. According to the principles of ISO 14006/2020, what is the most significant deficiency in this LCA approach from an ecodesign perspective? Option A. The LCA overemphasizes manufacturing energy, which is a less significant environmental impact compared to raw material extraction for electronic product packaging. Option B. The LCA's omission of distribution-related impacts, such as transportation emissions, is a more critical oversight than end-of-life considerations. Option C. The LCA's focus on microplastic generation is too specific and not a universally recognized environmental impact category within standard LCA methodologies. Option D. The LCA fails to adequately consider the full spectrum of environmental burdens across the packaging's life cycle, neglecting critical end-of-life impacts. The correct answer is D. The LCA fails to adequately consider the full spectrum of environmental burdens across the packaging's life cycle, neglecting critical end-of-life impacts. Explanation: the core of incorporating ecodesign principles, as guided by ISO 14006/2020, involves a life cycle perspective. When auditing an organization's efforts to integrate ecodesign into packaging, an internal auditor must assess whether the chosen life cycle assessment LCA methodology adequately addresses all relevant environmental impacts across the packaging's entire life cycle. This includes raw material extraction, manufacturing, distribution, use, and end-of-life management. For packaging, specific considerations are critical. The selection of materials significantly impacts resource depletion, energy consumption, and potential for pollution. For instance, using recycled content reduces the need for virgin materials and the associated environmental burdens. The design of the packaging itself influences material efficiency, potential for reuse, and ease of recycling or composting. Distribution impacts are related to weight and volume, affecting transportation emissions. End-of-life management, such as landfilling, incineration, or recycling, has distinct environmental consequences. Therefore, an LCA for packaging must not only quantify these impacts, but also identify opportunities for improvement at each stage. The auditor's role is to verify that the LCA is comprehensive, uses appropriate impact assessment methods, and that the findings are used to drive tangible ecodesign improvements in packaging, aligning with the organization's environmental policy and objectives. This systematic approach ensures that the ecodesign efforts are effective and contribute to reducing the overall environmental footprint of the product. Question 17. An internal auditor is reviewing an organization's ecodesign process, as guided by ISO 14006/2020. The organization manufactures modular outdoor furniture. During the audit, the auditor notes that the life cycle assessment, LCA, for a new product line focuses heavily on energy consumption and material toxicity, but does not explicitly consider the visual impact of discarded or weathered components in natural settings. Considering the principles of ISO 14006 and the potential for indirect impacts on visual pollution through material selection and end-of-life considerations, what is the most pertinent area for the auditor to investigate further to ensure comprehensive ecodesign integration? Option A. the specific regulatory compliance of the organization with local ordinances regarding aesthetic landscaping and public visual amenity standards. Option B, the marketing department's assessment of consumer perception regarding the visual appeal of the furniture's materials when new. Option C, the organization's internal policies on artistic expression and design innovation unrelated to environmental performance metrics. Option D, whether the LCA methodology used by the organization incorporates criteria that can indirectly influence the visual impact of materials and products at their end-of-life stage. The correct answer is D, whether the LCA methodology used by the organization incorporates criteria that can indirectly influence the visual impact of materials and products at their end-of-life stage. Explanation: ISO 14006-2020 emphasizes integrating environmental considerations into product design, which includes life cycle assessment, LCA. While LCA primarily quantifies environmental impacts across a product's life cycle, e.g., resource depletion, greenhouse gas emissions, ecotoxicity, it can also inform aspects related to visual pollution, particularly in the context of material selection and end-of-life management. Visual pollution, defined as the aesthetic degradation of landscapes or environments, can be indirectly addressed through ecodesign principles guided by LCA. For instance, an LCA might highlight the environmental burden associated with the disposal of complex composite materials that are difficult to recycle, leading to landfill accumulation. This accumulation, if not managed properly, can contribute to visual pollution. An internal auditor assessing an organization's adherence to ISO 14006 would look for evidence that the LCA process informs design decisions aimed at minimizing such impacts. This could involve selecting materials that are biodegradable, easily recyclable, or have a lower visual impact when disposed of. The auditor would verify that the organization's environmental management system, EMS, has mechanisms to translate LCA findings, including those that could indirectly affect visual pollution, e.g., through waste management and material choices, into design specifications and supplier requirements. The focus is on the systematic incorporation of ecodesign principles, where LCA serves as a tool to identify opportunities for improvement, including those that might mitigate visual pollution by promoting more sustainable material life cycles and waste reduction strategies. Question 18. An internal auditor conducting a review of an organization's environmental management system in accordance with ISO 14006-2020 is examining the ecodesign process for a new line of glass beverage containers. The auditor needs to verify that the ecodesign activities adequately address the life cycle impacts of these containers. What specific focus should the auditor place on the life cycle assessment, LCA integration, to ensure compliance with the guidelines for incorporating ecodesign? Option A, checking if the LCA exclusively quantifies greenhouse gas emissions during manufacturing, neglecting other potential environmental impacts like water usage or resource depletion in raw material sourcing. Option B, verifying that the LCA methodology explicitly considers the energy intensity of raw material extraction and high-temperature melting processes for glass, alongside the potential for increased recycled content and design for recyclability at the end-of-life stage. Option C, ensuring the LCA prioritizes the aesthetic qualities of the glass and consumer appeal over quantifiable environmental impact reduction across all life cycle stages. Option D, confirming that the LCA report primarily details the product's performance during the use phase, such as thermal insulation properties, without significant emphasis on upstream or downstream environmental burdens. Correct answer is B, verifying that the LCA methodology explicitly considers the energy intensity of raw material extraction and high-temperature melting processes for glass, alongside the potential for increased recycled content and design for recyclability at the end-of-life stage. Explanation: the core principle tested here relates to how an internal auditor, applying ISO 14006-2020 guidelines, would assess the integration of ecodesign into product development, specifically focusing on life cycle assessment, LCA, for a glass product. The question requires understanding that LCA is a tool for evaluating environmental impacts throughout a product's life cycle, from raw material extraction to end of life. For glass, key stages include raw material sourcing: sand, soda ash, limestone, manufacturing high energy consumption, emissions, use durability potential for reuse, and disposal/recycling energy for melting, landfilling. An auditor would look for evidence that these stages have been considered during the ecodesign process. Specifically, ISO 14006 emphasizes proactive environmental improvement. Therefore, the auditor would seek evidence of efforts to reduce impacts at each stage. This includes selecting raw materials with lower embodied energy or from sustainable sources, optimizing manufacturing processes to reduce energy and emissions, designing for durability and reusability during the use phase, and planning for effective end-of-life management, such as increased recycled content or design for disassembly. The auditor's role is to verify that the organization's ecodesign process systematically addresses these life cycle stages and their associated environmental aspects, as guided by ISO 14006. The question probes the auditor's focus on identifying and mitigating potential environmental burdens across the entire product lifecycle, aligning with the proactive and systematic approach mandated by the standard for integrating ecodesign. Question 19. During an internal audit of a company manufacturing advanced composite aircraft components, an auditor is assessing the integration of ecodesign principles as per ISO 14006-2020. The company utilizes carbon fiber reinforced polymers, CFRP, and glass fiber reinforced polymers, GFRP, which specific aspect of the life cycle assessment, LCA methodology, is applied to these composite materials, would the auditor most critically examine to ensure effective ecodesign integration and compliance with the standard's guidelines on material selection and end-of-life management? Option A. The assessment of user stage energy efficiency improvements in aircraft design resulting from the weight reduction achieved by using composite materials, without a thorough evaluation of the material's own life cycle impacts. Option B. The accuracy of the database used for estimating the embodied energy of virgin aluminum alloys and titanium, as these are common alternative materials in the aerospace industry. Option C. The documentation of supplier environmental performance certifications for raw materials like standard steel and plastics, which are used in non-structural aircraft interior components. Option D. The methodology used to quantify the energy consumption and emissions associated with the polymerization of resins and the curing processes, alongside the feasibility and environmental impact of advanced chemical or mechanical recycling techniques for separating constituent fibers and matrix materials at end of life. The correct answer is D. The methodology used to quantify the energy consumption and emissions associated with the polymerization of resins and the curing processes, alongside the feasibility and environmental impact of advanced chemical or mechanical recycling techniques for separating constituent fibers and matrix materials at end of life. Explanation. ISO 14006-2020 provides guidelines for integrating ecodesign into environmental management systems. When auditing an organization that utilizes composite materials in its product lifecycle, an internal auditor must focus on how the ecodesign principles are applied to manage the environmental aspects of these materials. A life cycle assessment, LCA, is a critical tool for this. The standard emphasizes understanding the environmental impacts associated with each stage of a product's life, from raw material extraction to end of life. For composites, this includes considering the energy-intensive manufacturing processes, the potential for hazardous substances in resins or reinforcements, and the challenges associated with recycling or disposal due to their inherent material properties. An auditor would verify that the organization has identified and assessed these specific impacts within its LCA framework, as mandated by ISO 14006 for ecodesign integration. This involves checking if the LCA methodology chosen adequately captures the unique environmental burdens of composite materials, such as the use of virgin petroleum-based resins or the difficulty in separating constituent fibers from the matrix for recovery. The audit would look for evidence of how these LCA findings inform ecodesign decisions, such as selecting bio-based resins, exploring advanced recycling technologies for thermoset composites, or designing for disassembly. The focus is on the systematic integration of LCA findings into the product development process to reduce environmental impacts throughout the lifecycle, aligning with the intent of ISO 14006. Question 20. During an internal audit of a manufacturing firm's ISO 2020 compliant environmental management system. An auditor is reviewing the integration of ecodesign principles. The firm uses life cycle assessment, LCA, to identify environmental hotspots in its product development and has begun generating environmental product declarations, EPD, for its new range of consumer electronics. Which of the following audit findings would most directly indicate a failure in the systematic integration of LCA and EPDs into the ecodesign process as per ISO 14006-2020 guidelines? Option A. The EPDs produced do not include comparative assertions or benchmark data against competitor products, limiting their utility for market differentiation. Option B. The LCA data used for EPD generation was sourced from a previous product generation without revalidation for current manufacturing processes, and the EPD does not clearly state the scope boundaries for the specific product variant being declared. Option C. The firm's ecodesign team primarily relies on qualitative expert judgment for initial design concepts, with LCA being applied only in the final stages of product development to validate existing choices. Option D. The LCA reports are stored in a centralized digital repository, but access controls are not fully implemented, allowing unauthorized personnel to view sensitive environmental data. The correct answer is B. The LCA data used for EPD generation was sourced from a previous product generation without revalidation for current manufacturing processes, and the EPD does not clearly state the scope boundaries for the specific product variant being declared. Explanation. The core of an internal auditor's role concerning ISO 14006-2020 and ecodesign is to verify the effectiveness and compliance of the organization's environmental management system, EMS, in integrating ecodesign principles. Life cycle assessment, LCA, is a fundamental tool for ecodesign, providing a comprehensive view of a product's environmental impacts across its entire life cycle, from raw material extraction to end-of-life disposal. Environmental Product Declarations, EPD, are standardized, third-party verified documents that communicate the environmental performance of a product based on LCA data. For an internal auditor, understanding how these tools are used within the organization's ecodesign process is crucial. The auditor needs to confirm that the LCA methodology employed is appropriate and robust, adhering to relevant standards like ISO 14040 and ISO 14044. Furthermore, the auditor must verify that the data used in the LCA is reliable, representative, and consistently applied. When EPDs are generated, the auditor must check that they accurately reflect the LCA results and are communicated in a transparent and compliant manner, adhering to relevant EPD Program Operator Rules E.g. EN 15804 for construction products. The auditor's role is not to perform the LCA or create the EPD, but to audit the processes by which these are conducted and utilized to support ecodesign objectives and demonstrate environmental performance improvements. This involves examining records, interviewing personnel, and observing practices to ensure that the integration of LCA and EPDs into the ecodesign process is systematic, effective, and contributes to the overall environmental objectives of the organization, as stipulated by the EMS. The auditor would look for evidence that ecodesign decisions informed by LCA are documented and that EPDs, where applicable, are used to support claims and communicate environmental aspects to stakeholders. Question 21. An internal auditor is reviewing the environmental management system of a municipal water utility to ensure compliance with ISO 14006-2020 guidelines for incorporating ecodesign. The audit focuses on the utility's drinking water treatment process, considering the life cycle stages of producing potable water, which phase presents the most significant opportunity for ecodesign interventions to reduce the overall environmental burden, as would be evaluated during an ecodesign-focused audit. Option A. The disposal of sludge generated during sedimentation and clarification processes. Option B. The energy and chemical inputs required for filtration, disinfection, and pH adjustment stages. Option C. The transportation of treated water through the distribution network to consumers. Option D. The raw water intake and initial screening of debris. Correct answer is B. The energy and chemical inputs required for filtration, disinfection, and pH adjustment stages. Explanation. The question assesses the understanding of how life cycle assessment (LCA) principles, as applied within ISO 14006-2020 guidelines for ecodesign, relate to the environmental impacts of drinking water treatment. Specifically, it probes the auditor's ability to identify the most critical phase for environmental consideration in a typical drinking water treatment process when viewed through an ecodesign lens. A drinking water treatment process involves multiple stages: raw water intake, pretreatment, screening, coagulation, flocculation, primary treatment, sedimentation, secondary treatment, filtration, tertiary treatment, disinfection, pH adjustment, and distribution. While all stages have environmental implications, the energy-intensive nature of pumping water, aeration, chemical dosing, and sludge management, particularly during filtration and disinfection, often contributes the most significant environmental burdens across various impact categories like global warming potential, acidification, and eutrophication. The distribution phase also consumes energy for pumping. However, when considering the asterisk incorporation of ecodesign asterisk as per ISO 14006, the focus is on designing out environmental impacts from the product's life cycle. In water treatment, this translates to optimizing processes that consume significant resources or generate substantial waste. Energy consumption for pumping and aeration, chemical usage for coagulation and disinfection, and the management of treatment byproducts, like sludge, are key areas where ecodesign interventions can be most impactful. The question asks for the asterisk most significant asterisk phase from an ecodesign perspective, meaning where design choices can yield the greatest reduction in environmental impact. The energy required for pumping and aeration during the treatment stages, coupled with the chemical inputs for purification and the subsequent management of residual materials, often represent the largest potential for improvement through ecodesign. Therefore, the combination of energy demand and chemical inputs within the core treatment processes, leading to the final product, is typically where the most substantial ecodesign efforts would be directed to minimize environmental footprint. The distribution phase, while important, is primarily about transport and often less amenable to fundamental ecodesign changes within the treatment plant itself compared to the core treatment processes. Question 22. During an internal audit of an organization implementing ISO 14006-2020, an auditor is reviewing the ecodesign process for a new line of electronic devices. The organization claims to have incorporated life cycle assessment (LCA) principles. Which of the following audit findings would most strongly indicate that the LCA principles have been effectively integrated into the ecodesign process, leading to demonstrable environmental improvements in product development? Option A. The Environmental Impact Assessment Report for the new electronic device includes a comprehensive list of all potential environmental indicators, categorized by life cycle stage, without specific design changes linked to these indicators. Option B. The organization maintains a library of LCA software and has conducted several cradle-to-grave LCA studies for comparable products in the past. Option C. The marketing department has prepared a brochure highlighting the product's environmental attributes, which were identified through preliminary environmental screening rather than a full LCA. Option D. The design team's decision to use recycled aluminum for the device casing was directly informed by an LCA identifying significant upstream environmental burdens associated with virgin aluminum production, and this decision was documented as a key ecodesign intervention. The correct answer is D. The design team's decision to use recycled aluminum for the device casing was directly informed by an LCA identifying significant upstream environmental burdens associated with virgin aluminum production, and this decision was documented as a key ecodesign intervention. Explanation: ISO 14006-2020 emphasizes the integration of environmental considerations into product development, with life cycle assessment (LCA) being a key tool. When auditing an organization's adherence to these guidelines, an internal auditor must assess how LCA principles are applied to identify and manage environmental aspects throughout a product's life cycle. The standard encourages a proactive approach, moving beyond end-of-pipe solutions to design for environmental improvement. This involves understanding the entire value chain, from raw material extraction to end-of-life management. The auditor's role is to verify that the organization's ecodesign process systematically incorporates LCA thinking enabling informed decisions that minimize environmental impacts. This includes verifying that the scope of the LCA is appropriate for the ecodesign objectives, and that the data used is reliable and relevant for identifying improvement opportunities. The auditor must also ensure that the results of the LCA are communicated and utilized effectively within the design and development process. The core of the audit in this context is to confirm that the organization is not merely performing an LCA as a standalone exercise, but is actively using its findings to drive tangible environmental improvements in product design and management, aligning with the overarching goals of ISO 14001 and the specific guidance of ISO 14006. The focus is on the application of LCA principles to achieve ecodesign objectives, not just the theoretical understanding of LCA methodologies. Question 23. An internal auditor is assessing a manufacturing firm's compliance with ISO 14006-2020, specifically examining the integration of ecodesign into the development of a new line of portable computing devices. The auditor is reviewing the life cycle assessment, LCA, documentation, which indicates that the primary environmental hotspots identified for these devices are related to the energy consumption during their operational use and the materials used in their casings. Given the guidelines for incorporating ecodesign, which aspect of the LCA data would be most critical for the auditor to scrutinize to ensure effective environmental performance improvement during the use phase of the hardware? Option A. The detailed breakdown of greenhouse gas emissions generated during the manufacturing of the primary semiconductor components. Option B. The accuracy and comprehensiveness of data quantifying energy consumption during the device's operational lifetime. Option C. The projected rate of material degradation and potential for landfill leaching at the end-of-life stage. Option D. The volume of post-consumer recycled content specified for the device's internal structural supports. The correct answer is B. The accuracy and comprehensiveness of data quantifying energy consumption during the device's operational lifetime. Explanation. The scenario describes an internal auditor evaluating a company's adherence to ISO 14006-2020 guidelines concerning the incorporation of ecodesign principles into product development, specifically focusing on hardware. The auditor is reviewing the life cycle assessment, LCA data used for a new electronic device. ISO 14006 emphasizes integrating environmental considerations throughout the product's life cycle, from raw material extraction to end of life. A critical aspect of this is understanding how LCA data informs ecodesign decisions. When evaluating hardware, particularly electronic devices, the use phase often represents a significant portion of the environmental impact, primarily due to energy consumption. Therefore, an auditor would look for evidence that the LCA data accurately reflects and quantifies the energy required during the product's operational life, as this directly influences design choices aimed at reducing environmental burdens, such as improving energy efficiency or extending product lifespan. The guidelines stress the importance of considering all life cycle stages, but the use phase's potential for ongoing impact makes it a focal point for ecodesign improvements in hardware. The auditor's role is to verify that the LCA data is comprehensive and applied effectively to achieve environmental improvements in the product design, ensuring compliance with the spirit and letter of ISO 14006. Question 24. During an internal audit of a food processing company that aims to integrate ecodesign principles into its environmental management system, what specific life cycle assessment, LCA, finding related to agricultural inputs would most critically inform the auditor's evaluation of the company's ecodesign efforts for a packaged vegetable product? Option A. Documentation of non-compliance with national food safety standards regarding pesticide residue levels on harvested produce. Option B. Analysis of the recyclability of the product's primary packaging material and its end-of-life management. Option C. Assessment of energy consumption patterns in the company's retail distribution centers and their contribution to greenhouse gas emissions. Option D. Identification of significant eutrophication potential stemming from nitrogen and phosphorus runoff from the cultivation of key raw vegetables. The correct answer is D. Identification of significant eutrophication potential stemming from nitrogen and phosphorus runoff from the cultivation of key raw vegetables. Explanation. The question probes the auditor's understanding of how to integrate ecodesign principles into an environmental management system, EMS, within the context of food production, specifically concerning life cycle assessment, LCA. ISO 14006, 2020 emphasizes incorporating environmental considerations into product development and design. In food production, a significant environmental impact often arises from agricultural practices, specifically fertilizer use, and its subsequent impact on eutrophication. When an auditor assesses an organization's EMS and its integration of ecodesign, they must verify that the organization is considering the entire life cycle of its products. For a food product, this includes raw material acquisition, processing, packaging, distribution, consumption, and end of life. The auditor needs to determine if the organization has identified significant environmental aspects across these stages, and if ecodesign strategies are being employed to mitigate them. Considering the options, a focus on reducing the environmental burden associated with fertilizer runoff into waterways, which directly addresses eutrophication, is a key ecodesign consideration in agriculture-based food production. This aligns with the principles of LCA and the goal of minimizing environmental impacts throughout the product life cycle, as guided by ISO 14006. The other options represent either broader EMS elements not specifically tied to ecodesign integration in this context, or impacts that might be less significant or less directly addressable through ecodesign in a typical food production LCA. For instance, while waste management is important, the specific impact of fertilizer-induced eutrophication is a more direct and critical area for ecodesign intervention in many food supply chains. Similarly, improving energy efficiency in retail is an important environmental consideration, but might be outside the direct scope of ecodesign for the food product itself, depending on the organization's product definition. Ensuring compliance with general food safety regulations, while crucial for an EMS, is not the primary focus of ecodesign integration. Question 25. During an internal audit of a manufacturing firm's ecodesign process, an auditor is assessing the effectiveness of integrating biodiversity considerations as guided by ISO 14006-2020. The firm claims to have incorporated biodiversity impacts into its product development. What specific aspect of the firm's ecodesign framework would the auditor most critically examine to verify this claim? Option A. The comprehensive inclusion of potential impacts on ecosystems and species across all stages of the product's life cycle within the firm's life cycle assessment, LCA, methodology. Option B. The firm's adherence to national regulations concerning the protection of endangered species in its immediate operational vicinity. Option C. The number of internal training sessions conducted for product designers on general environmental awareness related to biodiversity. Option D. The extent to which the firm has publicly communicated its biodiversity protection initiatives to stakeholders and regulatory bodies. Correct answer is A. The comprehensive inclusion of potential impacts on ecosystems and species across all stages of the product's life cycle within the firm's life cycle assessment, LCA methodology. Explanation. The question probes the auditor's understanding of how to integrate biodiversity considerations within an ecodesign framework, specifically in the context of ISO 14006-2020, a key aspect of ecodesign, and by extension ISO 14006, is the life cycle perspective. Life cycle assessment, LCA, is a fundamental tool used to evaluate the environmental impacts of a product or service throughout its entire life cycle, from raw material extraction to end-of-life disposal. When considering biodiversity, an LCA must extend beyond typical impact categories like climate change or resource depletion to encompass impacts on ecosystems and species. This involves identifying potential disruptions to habitats, species populations, and ecological processes at various life cycle stages. For example, raw material sourcing might lead to deforestation or habitat fragmentation. Manufacturing processes could result in water pollution affecting aquatic life, and product use or disposal might introduce invasive species or contaminants into natural environments. Therefore, an internal auditor verifying the integration of ecodesign principles according to ISO 14006-2020 would look for evidence that the organization has systematically evaluated these potential biodiversity impacts across the product's life cycle and implemented measures to mitigate them. This systematic evaluation of potential impacts on ecosystems and species throughout the entire product life cycle is the core of integrating biodiversity into ecodesign through an LCA lens. Question 26. During an internal audit of a construction firm's environmental management system, focusing on ISO 14006-2020 guidelines for ecodesign, what is the primary objective when evaluating the firm's application of life cycle assessment, LCA, for selecting building materials, specifically concerning the embodied energy of concrete versus sustainably sourced timber? Option A. Verify that the documented procedure for integrating LCA findings into material procurement decisions clearly prioritizes materials with lower embodied energy and cradle-to-grave environmental impacts, as demonstrated by comparative analysis. Option B. To ensure that the company's marketing materials accurately reflect the environmental benefits of the selected materials, as determined by their respective LCAs. Option C. To confirm the presence of a detailed LCA report for every single building material used, regardless of its contribution to the overall environmental footprint of the project. Option D. To assess the financial savings achieved by choosing materials with lower embodied energy, as this is a key performance indicator for sustainable construction practices. The correct answer is A. To verify that the documented procedure for integrating LCA findings into material procurement decisions clearly prioritizes materials with lower embodied energy and cradle-to-grave environmental impacts, as demonstrated by comparative analysis. Explanation. ISO 14006-2020 emphasizes the integration of ecodesign principles into an organization's environmental management system, EMS, when auditing a construction company's adherence to these guidelines, particularly concerning life cycle assessment, LCA. For building materials, an auditor must focus on how the company identifies and manages environmental aspects throughout the product's life cycle. The standard encourages a proactive approach to minimize environmental impacts. In the context of construction, this means evaluating materials from raw material extraction, manufacturing, transportation, use, and end-of-life stages. An auditor would assess the documented procedures for selecting materials based on their LCA data, ensuring that decisions are informed by environmental performance indicators. This includes verifying that the company has established criteria for evaluating the environmental burdens associated with material sourcing, embodied energy, potential for recycling or reuse, and waste generation during construction and demolition. The goal is to confirm that the EMS supports the systematic incorporation of ecodesign considerations, leading to improved environmental performance in the construction projects undertaken. Therefore, the auditor's focus should be on the process of integrating LCA findings into material selection and design, rather than just the final LCA report itself. This process ensures that ecodesign is embedded in the company's operational framework, as guided by ISO 14006. Question 27. An internal auditor is reviewing a company's adherence to ISO 14006-2020 guidelines for incorporating ecodesign, specifically focusing on a new electronic device designed for enhanced recyclability. The company's life cycle assessment, LCA, report claims significant environmental benefits at the end-of-life stage due to the product's design for disassembly and the use of recyclable materials. However, the auditor notices that the LCA's end-of-life phase primarily models a generic mechanical recycling scenario, without specifying the actual recycling technologies employed or the geographical location of the recycling facilities. Considering the principles of ISO 14006-2020 and the importance of accurate LCA data for ecodesign, what aspect of the LCA's end-of-life assessment would be most critical for the auditor to investigate further to validate the claimed environmental benefits? Option A. The LCA's evaluation of the product's performance during its use phase, such as energy efficiency, which is a separate but important aspect of ecodesign. Option B. The LCA's assessment of the product's overall embodied energy, from raw material extraction to manufacturing, irrespective of the end-of-life treatment. Option C. The LCA's detailed breakdown of energy consumption and emissions associated with the specific implemented recycling processes for the device's components, including sorting and reprocessing, and how these align with available recycling infrastructure. Option D. The LCA's consideration of potential market demand for recycled materials derived from the device, as this influences the economic viability of recycling. The correct answer is C. The LCA's detailed breakdown of energy consumption and emissions associated with the specific, implemented recycling processes for the device's components, including sorting and reprocessing, and how these align with available recycling infrastructure. Explanation. The core of this question lies in understanding how life cycle assessment, LCA, informs ecodesign principles within the framework of ISO 14006-2020, particularly concerning end-of-life scenarios like recycling. An internal auditor examining a company's ecodesign efforts would need to verify that the LCA data used for product development accurately reflects the environmental impacts associated with the chosen recycling pathways. ISO 14006-2020 emphasizes integrating environmental considerations throughout the product lifecycle, from raw material acquisition to end of life. When a product is designed for recyclability, the LCA should quantify the energy and resource inputs required for collection, sorting, reprocessing, and the creation of new materials from recycled content. It should also account for the environmental burdens of any residual waste that cannot be recycled. Therefore, the auditor must assess whether the LCA explicitly models the environmental performance of the specific recycling technologies and infrastructure available and utilized by the company or its partners, rather than making generalized assumptions. This ensures that the ecodesign choices, driven by the LCA, genuinely lead to reduced environmental impact at the end-of-life stage, aligning with the guidelines' objective of promoting sustainable product development. The auditor's focus is on the data's fidelity to real-world recycling processes and their associated environmental consequences, which is crucial for validating the ecodesign claims. Question 28. An internal auditor is reviewing the integration of ecodesign principles, guided by ISO 14006-2020, within an organization that produces organic coffee. The audit focuses on the environmental management system's effectiveness in utilizing life cycle assessment, LCA, data to drive product improvements. Considering the agricultural nature of the product and the requirements of ISO 14006-2020, which of the following audit findings would most critically indicate a deficiency in the organization's ecodesign process concerning the LCA application? Option A. The organization has conducted a comprehensive LCA that includes all cradle-to-grave stages, identifying the most significant environmental hotspots, and has documented how these findings have directly informed the selection of new packaging materials. Option B. The LCA methodology employed by the organization adheres to ISO 14040 and ISO 14044 standards, and the results have been used to modify the processing parameters to reduce greenhouse gas emissions. Option C. The organization has implemented a system to collect data on the environmental performance of its suppliers, which is then fed into the LCA, and has established a framework for periodically reviewing and updating the LCA based on new data. Option D. The LCA report identifies significant environmental impacts related to water usage during cultivation and energy consumption during roasting, but the ecodesign team has not yet established quantifiable targets for reducing these specific impacts in the next product iteration. The correct answer is D. The LCA report identifies significant environmental impacts related to water usage during cultivation and energy consumption during roasting, but the ecodesign team has not yet established quantifiable targets for reducing these specific impacts in the next product iteration. Explanation. The question pertains to the application of life cycle assessment, LCA, principles within the context of ecodesign, specifically for an agricultural product, and how an internal auditor would evaluate its integration into an environmental management system, EMS, according to ISO 14006-2020. ISO 14006-2020 emphasizes incorporating ecodesign into an organization's EMS to reduce environmental impacts throughout a product's life cycle. For an agricultural product, the life cycle stages are extensive, including raw material extraction, fertilizers, pesticides, farming land use, water consumption, energy for machinery, processing, packaging, distribution, consumption, and end-of-life disposal or recycling. An internal auditor would assess the organization's ability to identify and manage environmental aspects and impacts at each of these stages. When evaluating the LCA for an agricultural product, an auditor needs to verify that the methodology used is robust and aligns with the ISO 14040 and ISO 14044 standards, which provide the framework for conducting LCAs. The auditor would look for evidence that the organization has defined the goal and scope of the LCA, conducted an inventory analysis, collecting data on inputs and outputs, performed an impact assessment, evaluating the potential environmental impacts, and interpreted the results. For an agricultural product, key impact categories often include water depletion, eutrophication, acidification, global warming potential, and land occupation. The auditor's focus would be on how the LCA findings are used to inform ecodesign decisions. This means checking if the identified significant environmental aspects and impacts from the LCA have led to concrete actions to improve the product's environmental performance. For instance, if the LCA highlights high water consumption during the cultivation phase, the ecodesign strategy might involve promoting drought-resistant crop varieties or implementing efficient irrigation techniques. If energy consumption during processing is a major impact, the ecodesign might focus on energy-efficient machinery or renewable energy sources. The auditor would also check if the LCA is updated periodically to reflect changes in technology, regulations, or product design, and if the results are communicated effectively to relevant stakeholders involved in the ecodesign process. The selection of relevant impact assessment methods and characterization factors that are appropriate for agricultural systems is also a crucial point of verification. The auditor must ensure that the LCA is not merely a theoretical exercise, but a practical tool driving environmental improvement in line with the organization's EMS and ecodesign policy. Question 29. During an internal audit of an organization's ecodesign integration for building demolition projects, an auditor is examining how the company quantifies the environmental benefits of material recovery and reuse. The organization utilizes life cycle assessment, LCA, to evaluate its end-of-life strategies. Which of the following approaches would the auditor consider the most robust indicator of successful ecodesign implementation in this context, as per ISO 14006-2020 guidelines? Option A. Evaluation of the recyclability potential of various building components based on material composition and existing recycling infrastructure. Option B. Assessment of the economic feasibility and cost savings realized from recycling and reusing demolished materials. Option C. Quantification of avoided environmental burdens associated with virgin material extraction and processing due to material recovery and reuse. Option D. Tracking the total volume of construction and demolition waste diverted from landfill and sent for recycling or reuse. Correct answer is C. Quantification of avoided environmental burdens associated with virgin material extraction and processing due to material recovery and reuse. Explanation. The question pertains to the application of life cycle assessment, LCA principles within the context of ecodesign, specifically focusing on the end-of-life phase for building materials, particularly during demolition. ISO 14006-2020 provides guidelines for incorporating ecodesign into environmental management systems. A key aspect of ecodesign is minimizing environmental impacts throughout a product's life cycle, including its disposal or recovery. For building materials, especially those used in demolition, the environmental impacts are significant and multifaceted. When auditing an organization's ecodesign efforts related to demolition waste, an internal auditor needs to assess how effectively the organization is considering the environmental performance of material recovery and reuse options. This involves evaluating whether the organization's LCA methodology adequately captures the benefits of diverting materials from landfill. The environmental benefits of reusing or recycling materials, such as concrete aggregates or steel, are typically quantified in LCA by comparing the avoided impacts of virgin material production with the impacts of the recovery processes. For instance, if a ton of steel is recycled instead of producing a ton of virgin steel, the LCA would show avoided impacts related to mining, smelting, and transportation of raw materials. Similarly, Using recycled concrete aggregate reduces the need for quarrying and processing new aggregate. The auditor's focus should be on the robustness of the data and assumptions used to quantify these avoided impacts. The most comprehensive way to evaluate the environmental performance of material recovery and reuse in demolition, from an LCA perspective, is to quantify the avoided environmental burdens associated with virgin material extraction and processing. This directly addresses the core principle of ecodesign, reducing resource depletion and associated environmental impacts. Other options, while related to waste management, do not capture the LCA-specific quantification of environmental benefits as effectively. Simply tracking the volume of waste diverted from landfill is a waste management metric, not a quantified LCA benefit. Assessing the cost-effectiveness of recycling is a financial consideration, not an environmental performance indicator within an LCA. Evaluating the recyclability of materials without quantifying the actual environmental savings from their recycling does not fulfill the LCA requirement for demonstrating reduced environmental impact. Therefore, the most appropriate measure for an auditor to assess the ecodesign integration related to demolition material recovery is the quantification of avoided environmental burdens from virgin material substitution. Question 30. An internal auditor reviewing an organization's ecodesign process, guided by ISO 14006-2020, discovers that a life cycle assessment, LCA, for a new electronic device highlights significant volatile organic compound, VOC, emissions primarily occurring during the product's use phase, attributed to the solvent-based coatings on its external casing. Which of the following ecodesign strategies would the auditor most likely identify as a direct and effective response to this specific LCA finding, demonstrating a robust integration of environmental aspects into product development? Option A. Enhancing the product's recyclability at end of life by redesigning the casing to facilitate easier disassembly and material separation. Option B. Prioritizing the selection of raw materials for internal components with a lower embodied energy footprint during the manufacturing stage. Option C. Investigating and implementing alternative coating technologies that utilize water-based or powder formulations to minimize VOC release during the product's operational life. Option D. Developing a comprehensive take-back program to manage the disposal of used products, thereby mitigating landfill waste. The correct answer is C. Investigating and implementing alternative coating technologies that utilize water-based or powder formulations to minimize VOC release during the product's operational life. Explanation. The core of this question lies in understanding how life cycle assessment, LCA data, specifically concerning volatile organic compounds, VOC, informs ecodesign decisions within an ISO 14006 framework. VOCs are a critical environmental aspect due to their contribution to air pollution, including the formation of ground-level ozone and potential health impacts. ISO 14006-2020 emphasizes the integration of environmental considerations into product design and development. When auditing an organization's ecodesign process, an internal auditor would look for evidence that LCA findings are systematically used to drive improvements. In this scenario, the LCA data indicates that the primary VOC emissions during the product's use phase originate from the solvent-based coatings applied to the external casing. An effective ecodesign strategy, guided by LCA, would therefore prioritize addressing this significant impact. This means exploring alternative materials or processes that reduce or eliminate VOCs in the coatings. For instance, switching to water-based or powder coatings, or even exploring low VOC solvent alternatives would directly target the identified hotspot. The auditor would seek evidence of this exploration and its subsequent implementation or justification for not implementing it. The other options, while potentially related to environmental management, do not directly address the specific LCA finding of VOC emissions from coatings during the use phase, as the primary driver for ecodesign improvement in this context. For example, focusing solely on end-of-life recycling without addressing a major use phase impact is less efficient. Similarly, concentrating on raw material extraction impacts without considering the significant use phase VOC contribution would be an incomplete ecodesign approach. The question tests the auditor's ability to connect LCA results to actionable ecodesign improvements, prioritizing the most significant environmental aspects identified.